Now, Internet Protocol is not sufficient to send the data reliably over the network, because when these packets travel through the network, they might not take the same path to reach the destination machine, and so they might not reach in the sequence they were sent. And Internet Protocol has no way to identify the order of the packets at the receiver's end. So how would you reassemble the packets if you don't know the correct order? Also, sometimes the packets get lost in transit, which means that some packets never reach the destination. And again, Internet Protocol has no way to identify which packets did not reach the destination so that it can retransmit them. So, Internet Protocol doesn't guarantee that all the packets sent by the sender will be received by the receiver. So we can clearly see that the Internet Protocol is an unreliable protocol, and that is the reason why we use Internet Protocol along with TCP, short form for Transmission Control Protocol. So the Transmission Control Protocol ensures that the IP packets that were sent over the network reach the destination machine without omissions and in the same order as sent. Now, how does TCP ensure all that? And how does it work? Basically, the machines using TCP protocol establish the connection and agree on some parameters before sending any data. Parameters like source and destination port number, initial sequence number, window value, etc. etc. And this process of establishing the connection and exchanging some parameters before communication begins is known as a three-way handshake. So let's see how client and server performs a three-way handshake. So client sends a connection request by sending parameters like source and destination ports, initial sequence number, etc. And when the server receives this request, it decides whether it wants to communicate with the client or not. And if it wants to communicate, it will send the acknowledgement, basically acknowledging the request it received from the client. And finally, the client acknowledges the response of the server, and they both establish a reliable connection with which they will start the actual data transfer. And this is how devices using TCP establish a connection before transferring any data. But more importantly, TCP assigns a sequence number to every packet. And this is what the receiver of the packets use to reassemble the packets in order. If you remember, this was one of the issues with the Internet Protocol. Another very important use of sequence number is that it is used by the sender to identify the packets that were lost in transit. So what happens is, every time when a receiver receives a packet, it sends an acknowledgement for the same, kind of informing the sender that it received the packet with sequence number so and so. And if the sender doesn't receive the acknowledgement, it resends the packet until it gets the acknowledgement for the same. And by doing this, it ensures that the receiver receives all the packets. And this was again an issue with the Internet Protocol. So this is how TCP uses sequence numbers to solve issues with the Internet Protocol. So let's recollect what is an IP packet. The data is splitted into the data chunks, and then a header is prepended to it, which along with some other useful information contains the IP address of the sender and the receiver. And then a trailer is appended to it to mark the end of the data chunk. And this combination of header, data and trailer is known as an IP packet. Now what TCP does is that it adds its own header to the packet, which will contain the information like source and destination port numbers, sequence number, acknowledgement number, etc. Now, Internet Protocol provides information like source and destination IP address, which is useful for transferring the packets over the network. And TCP provides sequence numbers to the packets, which is used to identify the lost packets and to identify the order of the packets at the receiver's end. So TCP and IP together gives us a reliable communication, and hence they both are generally used together. And this combination of TCP and IP protocol is called the Internet Protocol Suite. Generally, it is simply called TCP/IP protocol. Okay? So, to summarize, first we learned that there are some issues with the Internet Protocol and that we can use TCP to resolve them. And then we saw how machines communicating over TCP establish the connection before transferring any data. Then we saw how TCP uses sequence number to solve the issues with Internet Protocol. Then we saw how TCP adds its own header to the Internet Protocol packet. And finally, we learned that the combination of these two protocols is known as the Internet Protocol Suite. Okay?